So the next thing I want to talk about a little bit is form, space, and order. Again, I'm going to be using a book from Francis D.K. Ching. It was published in 1986, or 96, sorry. And the book is entitled Architecture, Form, Space, and Order. This is the second edition. It's published in New York by Van Nostrand Reinhold. So the first thing I want to talk about is this whole notion of form. How does form come about? So when we look at a form, sometimes form is simply defined by its edges or its shape. So we see that this is a cube because we recognize its edges. Or maybe in a dark room, the entire object is blackened in and we only see its outline, as in this example right here. Sometimes its size helps us to define form. So this is where we look at the outer edge of an object. It's kind of similar to shape, but it's a little bit different because we can see that this one is much bigger than this one here, which helps us to differentiate these two forms. And color is another way that we can basically define form. And then we have texture. So sometimes your form may not necessarily have an edge, such as a shadow, like a hard edge. So instead we look at the color. And then we see texture, this being utilized a lot with paving patterns. You can define form using different paving patterns, which eventually helps you to define space. Going to the next slide here, we have position, orientation, and visual inertia. These are more ways that we can, kind of like tricks, that we can use to help define form. So the position of an object relative to two other objects can help us to define form. The orientation of this object compared to other objects can help us to define form. And the inertia, the seemingly visual appearance that it might be moving, helps also to define form. And you may see examples of this throughout the landscape. So let's go ahead and look at another example. Here. Alright, so here sometimes form can be looked at as the absence of form. So oftentimes we tend to, when we try to draft or define a form or a space, we always look at what is there. And sometimes what might help us with drafting, so a lot of times I see students try to draw this perfectly half circle here and try to get this angle just right. And this will take them, like, of course, several hours, some people like a couple days. And actually right now I'm working with a couple of fifth years who are actually dealing with this exact problem. They have a shape that looks like this, and they want to have these little round objects around the side here. It's actually a three-dimensional shape that comes across here like this. So if we were to take a section through here and look at this, it actually looks like this. It's very curved there. I'm not drawing it very well. And they want to have a shape that comes like this. It's like a little bracket or something to help support this shape. But they don't know how to get this angle right. And the other problem is that they have these ends here that come across like this. And they want to get rid of this and they want to get rid of that. And what they're looking at is they're actually looking at this right here. And they're trying to model this. And it's just not working out very well for them. So many students make this mistake. And instead of just looking at the little minute details, look at the form as a whole. Look at what's not there. So in this example here, what's not here is the rest of the sphere. So to solve this modeling problem, what they would do is they would just draw the sphere, or in this case the cylinder, as if it was there. And then what they would do is they would just trim this off. They would use this object, do a subtraction Boolean operation to trim this off. And what that will do is it'll make that edge perfectly curved with this little trough piece here. And you'll still have your sphere. You don't have to do any kind of mathematical calculations to figure out the curvature of this edge or anything like that. You'll get that effect. And many students make this mistake. I see it over and over many times. Instead of looking at what's not there, they look at only what they see there, and they don't see the whole form. So definitely, seeing what is not there can help accelerate your modeling experience. So here, we have a cylinder. Students will just stop here and try to model across there. Nope, you don't need to do that. Just draw the whole thing. And then do a Boolean operation and just subtract the missing piece. So in CAD, I keep mentioning Boolean operation. This is actually a 3D drafting tool, 3D modeling tool. Get rid of my sketches here. So I'm switching workspaces to 3D modeling. And if I go over here to solids, because that's what this group was trying to model, we see these Boolean operations. You can merge two solids together. You can subtract a couple of solids. So this is looking at what's not there. But in order to see what's not there, you have to see the whole. And then maybe you only want the intersection of the two objects. So down here is more examples of looking at what's not there. Common mistakes students will make is they'll try to model this notch, when all they really need to do is just do the huge square and then model the small square and then subtract one from the other. So subtraction is a very powerful tool. It's underutilized. Many students don't think of it. They just look at what's there and not focus on what's not there. So here are some examples of subtraction. So now this is a great opportunity to start talking about the different types of spatial organization. So this first one is a central type spatial organization. And the reason why I'm talking about this is part of modeling involves understanding the different types of spatial organizations that you have, and that kind of helps you get started when you need to model something. So we have a centralized form here, so meaning that everything is based off this point. The second one is linear. So linear is a series of forms arranged subsequently in a row, so everything is based off this line. Radial means that not necessarily it needs to start at the center, but things kind of move in an outwardly direction. So this is the key aspect of radial. And we can see here, if we read our definition, a composition of linear forms extending outward from a central form in a radial manner. And of course, cluster, this is probably one of the most difficultest things to model because there is no organization to these patterns here. So what you have to look at instead is other geometric similarities. So here in the definition it says a collection of forms grouped together by proximity or the sharing of a common visual trait. So when trying to model something that is in clustered form, you really have to use that visual subtraction or addition of form in order to adequately basically model clustered form. And then we have grid. Grid's pretty straightforward. You have this imaginary grid and everything is located based on this grid shape here. So here are some examples of a centralized form. So everything is based on the center piece right here. Go ahead and look at another example here. This is linear. So we can see that things start at a point and then they kind of extend out and everything is based on this linear form. We see this down here. And you could even argue that this one is a grid. But this grid was based off something very linear. Basically a sequence of spaces or forms that forms this linear pattern. Here we see radial. So we have something that maybe starts in the middle and then it works its way out. We see this a lot with buildings. They'll have something like dorm rooms. They have something here in the middle, and then there's views that kind of radiate out from that building. Scroll down another one here, and this one we see is kind of a mixture of things. This is more of a kind of a cluster organization. So it's, like I said before, it's very hard to basically find the pattern of what a cluster is. So we see down here we kind of have this sort of thing going on. But here, there's really no pattern here, so it's kind of hard to locate objects. And here we see that objects are based on their basic, the space, form, and order here is based on the outlining geometry. We'll see some more examples of this. And here they use basically a grid pattern. These are probably streets, and objects are basically within this grid pattern. So it helps them to define this space. So let's take a look at some more examples here. And here we have a grid system, and things are based off the grid. So we can see that many of the Japanese structures, they use a modular system, and walls and spaces are defined on this modular system. It's very interesting.